In this video, I want to look at solving logarithmic equations. And just like with exponential equations, there's going to be two types. So type 1. Log base a of x equal to log base a of y implies x equal to y. So if I have a single logarithm on each side, then I can just say x is equal to y. Here we have log of x squared plus 1 equal to log of x minus 2 plus log of x plus 3. So we're going to start by using properties of logs on the right-hand side. Since we're adding, we could take log of the product, x minus 2, x plus 3. And now that I have a log on both sides, I can write this as x squared plus 1 is equal to x minus 2x plus 3. Multiplying out the right-hand side, I'm going to go ahead and multiply it out and simplify it. We get x squared plus x minus 6. I'm going to subtract x squared from both sides. I get 1 equal to x minus 6. And then I can add 6 to both sides. And with logarithms, we do need to check our answers. We cannot take the logarithm of a negative number. The domain of logarithm is 0 to infinity, so I need to make sure I don't get logarithm of a negative number. Sticking in 7 up here, I would get log of 50, that's fine. Log of 5, that's fine, and log of 10. So this is my solution. Here, I have log x plus log x minus 1 equal to log of 4x. Once again, I'm going to use my properties that say if I'm adding, I can take the log of the product. So x minus 1 equal to log of 4x. That then gives me that x times x minus 1 is equal to 4x. Or x squared minus x is equal to 4x. I'm going to subtract 4x from both sides. Since I have a quadratic, I want to get everything on the same side. That gives me x squared minus 5x equal to 0. Factoring out an x, I have x and x minus 5. So that tells me x is equal to 0 and x minus 5 is equal to 0, or x is equal to 5. Once again, we need to check these. If I stick in 0, I have log of negative 1, which is bad. I cannot take the logarithm of a negative number. If I stick in 5, I have log of 5, that's fine. Log of 4, that's fine, and log of 20, that's fine. So my solution is just x equal to 5. Type 2 is going to look at things where not every term is a logarithm. I might have a logarithm equal to 4 or something like that. The first step is to get my logarithms on one side. Any term with a logarithm should be on one side of the equation. My second one is to combine any logarithms. So if I have multiple logarithms, I need to use my properties of logs to combine them. I'm then going to rewrite in exponential form. I'll then solve and check my solution. Let's start with a very basic one, ln of x equal to 8. My logarithms are already on one side, and I only have one, so I can start with step 3, moving to exponential form. This is base e to the 8th power is equal to x. So I have my solution, x is equal to e to the 8th. Now let's look at some more complicated examples. Log base 2 of 25 minus x equal to 3. Once again, I already have one logarithm on the side by itself, so I can move to step 3, which says convert. This is 2 to the 3rd power is equal to 25 minus x. We know 2 cubed is 8 equal to 25 minus x, and now we can solve. Subtracting 25 from both sides gives me negative 17 is equal to negative x, or x is equal to 17. Checking my solution, log base 2 of 25 minus 17 is 8. I don't take the logarithm of a negative number, so this is my solution. Here I have 4 plus 3 log 2x equal to 16. This time I'm going to have to start with my first step. I'm going to subtract 4 from both sides to write this as 3 log 2x equal to 12. I then need to divide both sides by 3, and I get log of 2x equal to 4. So I have my log on one side, everything else on the other. I do still only have one logarithm, so I can move to step 3. This is log base 10 since there's not a base. To the 4th power is equal to 2x. And now we can solve. 10 to the 4th power is 10,000. We can divide both sides by 2, and we get 5,000 is equal to x. Checking our solution, we would have a log of 10,000, which is perfectly fine. That's not a negative number, so this would be our solution. Here I have log of x plus 2 plus log of x minus 1 equal to 1. We do have our logarithms on one side by itself. However, we do have 2 of them, so I'm going to move to step 2. And it says to combine them. Adding means I multiply, so I have log of x plus 2, x minus 1 equal to 1. Moving to exponential, since I don't have a base here, it's base 10. To the 1st power is equal to x plus 2, x minus 1. And now we can solve. This is 10 equal to x squared plus x minus 2. You can subtract 10 from both sides. Since this is quadratic, we want to get everything on one side. We have x squared plus x minus 12. This factors into x plus 4, x minus 3. So we have x plus 4 equal to 0, or x is negative 4. We also have x minus 3 equal to 0, or x is 3. So let's check our solutions. If I stick in negative 4, I would have log of negative 2, which is not allowed. I cannot take the logarithm of a negative number. If I stick in 3, I would have log of 5. That's fine. And log of 2, that's fine. So my only solution is x equal to 3.